Hi and welcome back to a new video. About half a year ago, Intel launched Arrow Lake, aka Intel 200S on socket 1851. And when the CPU was launched, everybody was quite hyped, but then also often disappointed. The 285K was often more efficient than the predecessor, the 14900K, but in a lot of instances it didn't beat the performance, and sometimes it was even slower than the previous gen parts, which then led to disappointment and also to quite bad sales figures. And I also think that Intel figured this out. This is also probably one of the reasons why Intel kept working on the performance of Arrow Lake and also tried to keep improving the performance further. This is one thing we want to check out in today's video, because they now have the Intel 200S Boost, which is another performance uplift and supposedly the biggest one they have or did so far. You think your data is automatically GDPR compliant just because the server is located in Germany? It's actually not that simple. Due to the US Cloud Act, any American company can be forced to hand over data to US authorities even if it's hosted in Europe. European providers, like Hetzner on the other hand, are subject solely to EU data protection regulations and are therefore not affected by the US Cloud Act. With the right configuration and contracts, you can ensure that your data is secured in a GDPR compliant way. For example, with Hetzner Cloud, your data is not only GDPR compliant, it can also be scaled up at any time, flexibly and securely to meet your needs. You can find all further information in a €15 discount code for new customers in the video description down below. We will mainly focus in today's video on the Intel 285K, since this is the high-end part, but it also works with the 245K or also the 265K. When I'm talking about the 285K or Arrow Lake, I just mean the platform in general. The 285K or Arrow Lake is Intel's first desktop CPU, which is no longer monolithic, but it's using individual tiles making up a bigger chip. And those individual tiles, for example the GPU tile, which hosts the internal graphics unit, or the compute tile, which is hosting the P&E cores, or you could also have the SoC tile, which is hosting the memory controller. These individual chips or tiles, they can have internal clocks such as P-core clock or E-core clock, but also have communication within each other. For example, the compute tile with the SoC tile needs to have some bus in between. And you might remember this from AMD and also their first non-monolithic CPUs using multiple chiplets, that they also had issues with additional latency that was introduced and thus performance issues that came with it. And Intel has a similar problem with Arrow Lake, and this is what 200S Boost tries to battle. Intel 200S Boost was implemented in form of a BIOS profile, which you can easily just enable or disable. Intel pre-briefed me about this topic about a week ago to give me the opportunity to test this and also see what kind of performance uplift we would see. And when they briefed me, I was like, okay, but what does 200S Boost actually do? And at this point, we would get back to the tiles and the data connection within each other. And here is the list of what is actually happening. Intel 200S Boost is somewhat of an overclocking profile, which alters three general settings to the CPU and the memory. First of all, it alters or increases the NGU clock. That is a clock within the SoC tile. It is increased from 2.6 to 3.2 GHz. Then the D2D clock is improved, which is the compute tile to SoC tile connection, from 2.1 to 3.2 GHz. And the third thing that is improved is the memory clock, from previous max 6400 megatransfers to now 8000 megatransfers. Most of the time you would expect like a microcode update for some sort of performance fixes, but in this case it's just an overclocking profile. And what I find personally interesting about this, that it's outside of the original 285K or Intel Arrow Lake specifications, but is now covered under warranty. So Intel is basically expanding the specs without doing that. So they just allow overclocking to these settings while still cover this with warranty, which is odd but also very interesting. Especially the memory topic to me personally was quite interesting, because previously Intel listed the 285K or Arrow Lake with max 6400 megatransfers. And this definitely also has an impact on reviewers, because most of the time when you're getting a new CPU and you're comparing it with, for example, a competition like AMD, you would compare it with what is within the specs. What is the manufacturer saying? For example, AMD 9950X 3D, the spec is max 5600 megatransfers on the memory. And previously on Intel it was 6400. But now they're increasing this to 8000 megatransfers under warranty, which is, to me personally, quite interesting and definitely can also change reviews for the future that will be done with this platform. In my call with Intel, I also asked them how this is possible that they're suddenly expanding not really the specs, but the warranty by such a huge margin, because from 6400 to 8000, that is a rather huge jump and something I haven't seen before. And then they just said that they basically underestimated how good their own memory controller is. And now after half year, they figured out, after looking at just a broader range of CPUs, just a lot bigger or a bigger amount of samples, that they are confident in just giving warranty for a higher frequency. The big question is obviously how much does this help, and for this I tested with the C890A packs and two different memory kits. One memory kit within the original specification of 6400 C34 from G.Skill and another G.Skill kit with 8000 C38 with the Intel 200S boost. There is one more limitation to stay within the warranty using Intel 200S boost, and that's the voltage, which has to stay less or equal for VCCSA of 1.2 volt and less or equal 1.4 volt on the memory modules. There are a lot of DDR5 memory kits out there, especially with high frequency, that use 1.45 volt on the DIMM voltage, which also means that this would not work with the 200S boost profile if you would want to keep the warranty. And in that case, if you would apply for the 200S boost, it would set the memory voltage to 1.4 volt, and you would have to test if it still works with the memory frequency, or if you would have to manually downclock your memory modules, for example, to 7600 or 7800. I also asked Intel in the call what the reason for this is, why they went for only 1.4 volt, and they said that they didn't verify anything above and they just can't know how it would possibly affect the aging of the memory controller, because the DIMM voltage can have an impact on the memory controller itself and thus on the aging of the CPU, and since they're not 100% sure, they can only give warranty for 1.4 volt on the memory voltage. Now the first benchmarks, and I first tested AIDA64 to see what kind of impact we see in general when it comes to speed and latency. On the left you see the run done with 6400 megatransfers on the memory and the CPU being stock, and on the right with the 200S boost profile, which is putting the memory to 8000 and increasing the clock of both D2D and NGU, as you've seen it in the table. We see an increase in reading and write performance of about 30 GB per second, while also reducing latency by about 20 nanoseconds, which is quite a lot. One quick note, what is read out here as Northbridge clock is not correct. But what does this mean for gaming? That's probably the more relevant question. I tested 7 games in a CPU bottlenecked scenario, for example here Remnant 2 in 1080p resolution, and we just have to look at our RTX 5090, which you can see is basically consuming half of what it's normally doing. Typically we would expect about 500 to 550 watts power draw. Now it's more like 260 to 270, which indicates a heavy CPU bottleneck. This also implies that whenever you're running a more realistic or daily scenario, for example in 1440p or 4K resolution, more towards the GPU bottleneck, you would see less of an impact, which is obvious, but we want to see how much or if it even helps, and for this we just run a CPU bottleneck scenario. I will quickly run through the benchmarks. You can obviously pause if you want to take a look at something in more detail. In Cyberpunk, we can see an increase from 156 to 175 PS, which results in an increase of 12%. In Remnant 2, the performance increased by 18%, which is actually quite a lot. In Valorant, it was a little bit less, but still 840 to 900 FPS, and with this 7%. PUBG definitely surprised me with an increase of 19%. Counter-Strike 2 previously had issues, at least for me, with the 285K, and here the performance improved by 12%. Assassin's Creed Mirage also improved more than I expected, with additional 14% in performance. The smallest uplift in performance I could observe with Star Wars Outlaws, with only 4%. But I guess this is just because it's a newer game, and even in 1080p we're still somewhat running into the GPU bottleneck instead of the CPU bottleneck. In these 7 games that I tested, I on average saw a performance uplift of 12%, which is quite nice for just flipping a BIOS setting or a BIOS profile. And then I was basically done with my testing, and then I thought, but yeah, the information is not really useful unless we know how far we still are away from the AMD 9950X 3D, or if Intel maybe can even beat it. But I have to say that Intel doesn't really have a chance here. And again, we're running quickly through the benchmarks. In Cyberpunk, the 9950X 3D is 7% faster than the 285K. In Remnant 2, AMD is 21% faster than Intel. But it gets even crazier. If we look at Valorant in 4K resolution, the 9950X 3D, if you look at the 1% lows, is 48% faster than Intel's 285K. Also in PUBG, I could see a rather big performance difference between the both CPUs, with the AMD 9950X 3D being 37% faster than Intel. Very similar also in Counter-Strike 2, I saw 38% performance difference. And in Assassin's Creed, AMD is 19% faster. The only thing where Intel was performing quite well was Star Wars Outlaws, beating AMD by 3%. This means that the 9950X 3D on average in the 7 games that I tested is still about 20% faster than the 285K using the new 200S boost profile. Yet I'm still happy to see that Intel keeps improving the performance of Arrow Lake, didn't just abandon the platform, especially for the people who already bought the platform. This is something really good, that they can also manually overclock this, because you don't have to use the 200S boost profile if you want to. You can also manually overclock the NGU and D2D clock accordingly, and also increase the memory speed to 8000 megatransfers while maintaining the CPU manufacturing warranty, which is great. When 1851 was launched, people were under the impression that the 285K, or the first Arrow Lake generation, the 200S, will be the only generation for this socket. At least there are rumors now stating that there will be an Arrow Lake refresh, probably, I don't know, end of the year, early next year, something like that, where we will see another CPU generation for the socket. Not really a generation, but at least an Arrow Lake refresh, so maybe even more performance, maybe they can fix more things, and we will see something like, I don't know, a 385K. And then I'm happy to test it again, but right now, the 200S boost is a cool feature, especially for people who already have the platform. But from my perspective, it doesn't really change the general setting of AMD currently still being much better. I hope you enjoyed this. See you next time. Bye bye.